The PAPILLON system leverages DSPy's modular architecture to implement privacy-preserving interactions with external language models, employing declarative signatures to define task-specific behaviors and chain-of-thought reasoning for request transformation. This framework demonstrates how local models can strategically utilize untrusted but powerful external LLMs while maintaining user privacy through carefully crafted request redaction. We will examine the implementation of two core signatures that form the foundation of PAPILLON's privacy-preserving pipeline, followed by the module composition that orchestrates the interaction between trusted local processing and untrusted external LLM assistants.
Class craft redacted request SPy signature. Given a private user query, create a privacy-preserving request for a powerful external LLM. The LLM may assist without learning private information about the user. User query equals DSPy, input field. LLM request equals DSPy, output field. Class respond to queried SPy, signature. Respond to user query. For inspiration, we found a potentially related request to a powerful external LLM and its response. Related LLM request equals DSPy, input field. Related LLM response equals DSPy. Input field desk equals information from a powerful LLM responding to a related request. User query equals DSPy. Input field desk equals the user's request you need to fulfill. Response equals DSPy. Output field desk equals your final response to the user's request. Class PAPILLON in DSPy module. Def in itself, untrusted model. Self-craft redacted request equals DSPy. Chain of thought craft redacted request. Self-respond to query equals DSPy. Predict respond to query. Self-untrusted model equals untrusted model. Def forward self, user query. Try. LLM request equals self. Craft redacted request user query equals user query. LLM request. LLM response equals self. Untrusted modelm request 0. Response equals self-respond to query. Related LLM request equals LLM request. Related LLM response equals LLM response. User query equals user query. Response. Accept exception. Return DSPy. Predictional request equals LLM response equals response equals. Return DSPy. Predictional request equals LLM request. LLM response equals LLM response. Response equals response.
The PAPILLON system implements a privacy-preserving delegation framework where a trusted local model interacts with an untrusted external LLM to balance response quality and privacy. The architecture uses two core components: craft redacted request and respond to query, both implemented as DSPy signatures. The craft redacted request module uses chain of thought to transform user queries into privacy-preserving requests for the external LLM, while respond to query leverages the external LLM's response to generate the final user-facing output. This two-stage approach allows the system to benefit from the external LLM's capabilities while minimizing exposure of sensitive information. The implementation demonstrates a modular design pattern where each component has a clear responsibility. The PAPILLON class orchestrates the workflow. It first crafts a redacted request, sends it to the untrusted model, then uses both the original query and the external response to generate the final answer. This separation of concerns makes the system more maintainable and allows for independent optimization of each component. The use of DSPy's built-in modules like chain of thought and predict provides a clean abstraction over the underlying prompting techniques. The privacy-preserving nature of this design comes with trade-offs. While it protects user data by redacting sensitive information before sending to the external LLM, This redaction process might reduce the quality of responses if critical context is removed. The system's effectiveness depends heavily on the craft redacted request, module's ability to balance privacy and information retention. The architecture also assumes the local model has sufficient capability to craft effective redacted requests and synthesize final responses, which may limit performance when using smaller local models. This pattern is particularly valuable in scenarios where privacy is paramount, but some external computation is necessary for quality responses. Let's break it down.
Class craft redacted requests be signature.
Defines a new DSPy signature class named craft redacted request that inherits from DSPy signature. This establishes a declarative specification for a DSPy module's input-output behavior, where the class name indicates it's designed for crafting redacted requests. The inheritance from DSPy signature means this class will follow DSPy's signature pattern for defining LM task behavior.
Given a private user query, create a privacy-preserving request for a powerful external LLM.
Defines a privacy-preserving request signature for external LLM queries. The signature declares input fields for the user's private query and output fields for the sanitized request, establishing a clear interface for transforming sensitive user input into a format safe for external processing while preserving the query's intent.
The LLM may assist without learning private information about the user.
Imports the DSPy module, which provides a framework for declaratively specifying language model behavior through signatures and modules. This enables creating structured prompts and optimizing LM interactions without manual prompt engineering.
User query equals DSPy input field.
Creates an input field named user query using DSPy's input field class, which defines a placeholder for user-provided input in a DSPy signature. This field will be used to capture and pass user queries to a language model module.
LLM request equals DSPy output field.
Creates an output field named LLM request using DSPy's output field class, which defines a structured output specification for a DSPy module. This field will be used to declare and constrain the expected output format when interacting with language models in a DSPy signature.
Class respond to queried signature. Respond to user query.
Defines a DSPy signature class named respond to query that inherits from DSPy signature, establishing a declarative specification for a module that will handle user queries. The class includes a docstring indicating its purpose, responding to user queries, which will be used by DSPy to generate appropriate prompts or fine-tunes for language models.
For inspiration, we found a potentially related request to a powerful external LLM and its response.
Defines a DSPy signature class named GenerateAnswer with input field context and output field answer, specifying the expected input-output behavior for a language model task. The class-based signature provides a structured way to declare the module's behavior while allowing DSPy optimizers to handle prompt tuning.
Related LLM request equals DSPy input field.
Creates an input field named related LLM request using DSPy's input field class, which defines a parameter for a DSPy signature that will accept external input data during module execution. This establishes a structured input slot that can later be populated with relevant LLM request data when the signature is used in a pipeline.
Related LLM response equals DSPy. Input field desk equals information from a powerful LLM responding to a related request.
creates an input field named related LLM response using DSPy's input field class, with a description specifying it contains information from a powerful LLM responding to a related request. This defines a typed input parameter for a DSPy signature, where the desc parameter provides semantic context about the expected content.
User query equals DSPy. Input field desc equals the user's request you need to fulfill.
Creates an input field named user query using DSPy's input field class, with a description specifying that it represents the user's request you need to fulfill. This defines a semantic input parameter for a DSPy signature, where the desc parameter provides context about the field's purpose to the language model.
Response equals DSPy. Output field desc equals your final response to the user's request.
Creates an output field named response using DSPy's output field class, with a description specifying it should contain the final response to the user's request. This defines the expected output structure for a DSPy module, where the field will hold the LM's generated response that directly addresses what the user asked for. The desc parameter provides semantic context about the field's purpose within the signature.
Class PAPILLON in DSPy module.
Defines a new DSPy module class named PAPILLON that inherits from DSPy module, establishing it as a custom module within the DSPy framework. This creates the foundational structure for implementing PAPILLON-specific functionality while leveraging DSPy's module capabilities for language model integration.
Def in itself, untrusted model.
Defines the constructor method for a class that takes a single parameter, untrusted model, which will be used to initialize an instance of the class. The method is named init, indicating it's the standard Python constructor that runs when creating a new object. The parameter, untrusted model, suggests this class will work with an external or potentially untrusted model, likely in a privacy-preserving framework like PAPILLON, where local models interact with remote models cautiously.
Self-craft redacted request equals DSPy. Chain of thought craft redacted request.
Creates a chain of thought module instance named craft redacted request that uses the craft redacted request signature. This module will process inputs according to the signature's specification while employing chain of thought reasoning to generate outputs.
Self-respond to query equals DSPy. Predict respond to query.
Creates a DSPy predict module instance named respond to query that uses the respond to query signature to define its input-output behavior. This sets up a callable module that will process queries according to the specified signature when invoked.
Self-untrusted model equals untrusted model.
Assigns the provided untrusted model to the instance variable self-untrusted model, storing a reference to the model for later use within the class.
Def forward self user query.
Defines a method named forward that takes self and user query as parameters. This is the entry point for processing a user query in a DSPy module, where user query represents the input to be processed by the module. The method is part of a class-based DSPy signature, indicating it will handle the core logic for transforming the input query into an output.
LLM request equals self. Craft redacted request user query equals user query. LLM request.
Calls the craft redacted request method with the user query parameter, then accesses the LLM request attribute from the returned object and assigns it to the variable LLM request. This line effectively processes the user query through a redaction pipeline and extracts the prepared LLM request object for further use.
LLM response equals self. Untrusted mod elm request 0.
calls the untrusted model with the provided LLM request, and stores the first element of the returned result in the variable LLM response.
Response equals self-respond to query.
Calls the respond to query method on the current instance, self, and assigns the returned value to the variable response. The method is invoked without any visible arguments in this segment, suggesting it either takes no parameters or relies on instance state set elsewhere.
Related LLM request equals LLM request. Related LLM response equals LLM response. User query equals user query.
Creates a dictionary with 3 key value pairs. Related LLM request mapped to the value of LLM request. Related LLM response mapped to the value of LLM response. And user query mapped to the value of user query. This appears to be organizing related LLM interaction data into a structured format for potential use in a DSPy signature or module.
Response
accesses the response attribute of the preceding object, retrieving the output generated by a DSPy module after processing inputs. This is the standard way to extract the final result from a DSPy module call, where the response contains the LM's generated output based on the module's signature and provided inputs.
Accept exception.
Catches all exceptions that might occur in the preceding try block, allowing the program to handle errors gracefully without crashing. This is a broad exception handler that will intercept any exception type not previously caught by more specific handlers.
Return DSPy. Prediction request equals LLM response equals response equals.
Returns a DSPy. Prediction object with empty strings for LLM request, LLM response, and response fields. This creates a structured output container where all 3 fields are initialized as empty strings, likely serving as a placeholder or default return value in a DSPy module.
Return DSPy. Prediction request equals LLM request, LLM response equals LLM response, response equals response.
Returns a DSPy prediction object containing 3 fields: the original LLM request, the raw LLM response, and the processed response. This packages the complete interaction context into a structured output that can be used by other DSPy modules or for evaluation. PAPILLON's architecture demonstrates a clean separation of concerns through 2 specialized DSPy signatures working in sequence. The craft redacted request, module first transforms sensitive user queries into privacy-preserving requests using chain-of-thought reasoning, while respond to query synthesizes the final response by combining the original query with the external LLM's output. This 2-stage pipeline allows the system to leverage powerful but untrusted external models while maintaining privacy through strategic information redaction. The modular design enables independent optimization of each component, with the PAPILLON class orchestrating the workflow by chaining these modules together. The trade-off is clear. Privacy protection through redaction may reduce response quality if critical context is removed, making the system's effectiveness dependent on the local model's ability to craft effective redacted requests and synthesize responses. This pattern is particularly valuable when privacy is paramount, but external computation is necessary for quality responses.
The trusted module whispers, secrets it never hears, then answers with knowledge it never touched.